You know, it's funny. Have you ever really stopped to think about the device that's playing this for you right now? I mean, a speaker. It's everywhere, right? In our phones, our cars, our headphones. It's this little piece of everyday magic that we totally, completely take for granted. Well, today, we're going to pull back that curtain and see just how incredible this invention really is. I want you to just imagine something for a second. What if every single sound, the moment it was made, was just gone? Poof, forever. Think about it. A word you say, your favorite song, a baby's first laugh. It would just exist for a split second and then vanish into total silence. And the crazy thing is, that was reality. For pretty much all of human history, that's just how it worked. I mean, we could build the pyramids, we could cross entire oceans, but we couldn't hold on to a single sound. It was just temporary, gone. And trying to capture it, that was one of the biggest unsolved problems we had. So, how did we finally solve it? Well, the solution, when it finally came, was from a force we were only just starting to wrap our heads around: electricity. This was the key. This is how we finally figured out how to give sound a second life. Okay, so to really get this, we have to know what sound actually is. And it's not magic, it's pure physics. It's just vibrations. That's it. Little pressure waves pushing and pulling the air around you. When those waves vibrate really fast, we hear a high pitch. And when they're big and powerful, we hear a loud volume. It's really that simple. And this was the huge light bulb moment. You had inventors like Alexander Graham Bell messing around with the early telephone, and they figured out that those sound vibrations, they could be translated into an electrical signal that goes up and down. And that led to this absolutely revolutionary idea. If you can turn sound into electricity, well, then you got to be able to reverse it. You can turn that electricity back into sound. That was the key that unlocked everything. Okay, but there was a big problem. Those early telephone earpieces, they were super weak. You literally had to press them right up against your ear to hear anything. What the world really needed was a way to make that sound loud. Loud enough to fill a room, loud enough for everyone to hear. The race was on to create a true loudspeaker. Now, this didn't happen overnight. It was a slow burn. In the 1870s, you had those weak little earpieces. Then in the early 1900s, people were experimenting with these kind of crude horns and buzzers. But the massive leap, the real game changer, came in 1925. Two guys, Edward Kellogg and Chester Rice, invent the moving coil loudspeaker. And that design, it's basically the blueprint for almost every single speaker we use today. So how does this thing actually work? It's kind of like a beautiful little dance. Okay, step one. An electrical audio signal, basically your music, flows into a coil of wire. That creates a magnetic field that's constantly changing. Now, this coil is sitting next to a regular, permanent magnet. And because those magnetic fields are interacting, it forces the coil to vibrate back and forth like crazy. That coil is attached to a cone, the part you can see. And as the cone moves, it pushes the air, and boom, it creates the exact sound waves you hear. It's just this elegant mechanical process. And you know what's cool? This isn't just some clever bit of engineering. It's fundamental physics. The whole thing works because of something called the Lorentz force law. All that really means is, if you put a wire with electricity running through it, that's our voice coil, inside a magnetic field, it's going to get pushed. It's going to experience a force. In a speaker, that tiny little push is the sound. All right, so mission accomplished, right? We figured out how to make sound loud. But that was only half the battle. The next big challenge was making it sound good. Making it accurate. Because think about it. Making a deep, booming bass note is a totally different physical challenge than making a tiny, delicate, high-pitched sound from a cymbal. And the problem is all physical. It's all about moving air. For those low bass frequencies, you have to move a ton of air. That means you need a big, heavy cone making these large, slow movements. But for the high frequencies, the treble, you need the complete opposite. You need a tiny, lightweight cone that can zip back and forth thousands of times a second with incredible precision. And there's just no way a single speaker driver can be good at both of those jobs. So what was the solution? Well, you build a team of specialists. It's like a band. In any good speaker, you've got a big woofer whose only job is to handle the bass. Then you have a small, fast tweeter just for the high-frequency treble. And a lot of the time, you'll have a mid-range driver for the stuff in the middle, like voices. But how do they know who plays what? That's where this brilliant little thing called a crossover circuit comes in. It's like the traffic cop or the band manager. It takes the full music signal, splits it up, and sends only the low notes to the woofer and only the high notes to the tweeter. It's genius. And it's not just about the size of the speaker either. The actual material the cone is made from makes a huge difference to the sound. I mean, the very first speakers used paper, and a lot of people still love it for its warm, natural sound. But today, engineers use all sorts of crazy stuff. Polypropylene gives you a nice, smooth, versatile sound. You've got Kevlar, yep, the same stuff in bulletproof vests, which is super stiff and gives you really precise, detailed audio. Or even aluminum, which is incredibly rigid for those really crisp, bright high notes. Every single choice is a trade-off, all to get a very specific kind of sound. Okay, here's something you might have wondered about. If you've ever seen a speaker driver just by itself, without the big wooden box around it, and you hook it up, it sounds terrible, just thin and awful with no bass at all. So why is the box so important? What's it actually doing? Well, the answer is another cool physics problem called destructive interference. See, as the cone pushes forward to make a sound wave, it's also creating the exact opposite wave from the back. And if those two waves meet in the open air, they literally cancel each other out, especially the bass. It just disappears. The speaker box is the clever solution to this. A sealed box just traps that pesky back wave so it can't cause trouble. But a ported box does something even smarter. It uses a little hole, a port, to let that back wave come out, but in a way that it actually lines up with and reinforces the bass from the front. So clever. And for decades, that was basically the state of the art: magnets, coils, cones, and boxes. But then, the digital revolution happened, and it completely transformed the speaker from just a passive thing that plays sound into an active, intelligent piece of tech. And this evolution happened incredibly fast. First, you get these super efficient new amplifiers that made portable speakers a real thing. Then, in the 90s, Bluetooth comes along and cuts the cord completely. But the real game changer, the thing that changed everything, was something called digital signal processing, or DSP. And that technology leads us directly to the AI-powered smart speakers that are in so many of our homes today. So what is this DSP really? Think of it like a tiny brain, a little computer living inside the speaker. It's a microchip that is constantly analyzing the audio signal in real time. We're talking thousands of times a second. It's making all these tiny corrections. It can boost the bass on a really small speaker. It can get rid of distortion. It can totally fine-tune the sound to be perfect. And it does all of this before the signal even gets to the actual speaker parts. It's not just playing music anymore. It's actively managing it. So, when you take a step back from all the technical stuff, the magnets, the cones, the digital circuits, you start to see what a speaker really is. It's so much more than just a simple device. When you boil it all down, at its very core, a speaker is a translator. It's an energy converter. It performs this three-step process that is honestly kind of miraculous. It takes invisible electrical energy, turns it into real, physical, mechanical motion, and that motion creates acoustic energy, the sound waves that hit our ears, from electricity to movement to sound. And in the end, this whole technology, it's not just about physics and wires. It's about bringing moments back to life. It lets music, voices, entire stories be reborn again and again and again, all through the simple act of making the air around us vibrate. I mean, think about that journey. We went from a sound being a fleeting moment that was gone forever to being able to hold it, to share it, to perfect it. We learned to command these invisible forces of sound and electricity. And it really makes you wonder, doesn't it? What's next? What other invisible forces are out there all around us right now, just waiting for us to figure out how to translate them?